Hello everyone, welcome to Maths Easy. Here's another exam style question for A-level physics. A student connects a filament lamp to a battery that has internal resistance. He then adds another identical lamp in parallel with the first one as shown in the diagram. The student continues to add more identical lamps in parallel. He notices that each lamp becomes dimmer as more added, and the battery gets warmer. Explain why the brightness of the lamps decreases and why the battery's temperature increases as more lamps are added. So this is probably worth 5 marks. So pause the video. It's a really good question. Think about it. Give it a try. Jot down the points that you would write. And when you are ready to check the answer, press play. Now, let's try and understand what this question is really saying. A student connects a filament lamp to a battery that has internal resistance. So, the EMF is E, there is internal resistance R. He then adds another identical lamp in parallel. So, this is the first one, and he adds another one in parallel, this one. Then what he does is, he continues to add more identical lamps in parallel. Oh, so then he adds another one, like that. Then he adds another one, and so on and so forth. He keeps on adding these lamps. Just continue adding it. Now, he notices that each lamp becomes dimmer as more are added. Oh, okay. So why did that happen? And the battery gets warmer, right? So you need to give the reasons for these things. When more bulbs are connected in parallel, the total resistance of the external circuit decreases. Now, why does that happen? When you provide more and more identical resistors, so what happens to the total resistance? When you have two resistors, the total resistance of the external circuit is R over 2. That's for 2 of them. Let's say you have 3. Now the total resistance is R over 3. When you have 5, it's R over 5. So what happens? The higher the number of parallel branches you add, the lower the resistance. So when more bulbs are connected in parallel, the total resistance of the external circuit decreases, gets you 1 mark. Then this increases the current in the circuit according to V is equal to E minus IR. As I increases, V decreases. Now you can clearly see that when the total resistance decreases, the current increases. When the current increases, V is equal to E minus IR. So what will happen? The IR product increases. So the V decreases. So now the implication of that is the voltage across the external circuit decreases with time, right? When you add more and more resistors, more and more bulbs, the voltage across the external circuit decreases. Now, when this happens, the potential difference across the internal resistance increases. Now, as the voltage across the external circuit decreases, because P is equal to V squared over R, so what happens is the power output of the bulb decreases and they become dimmer. Now, as the resistance is less, the current is more. When there is more current through the battery, now what happens? The power dissipation in the battery, that's P is equal to I squared lowercase r. When I increases, what happens? When I increases, this increases. That means the power dissipation increases. So this explains why the battery heats up. So we can write that this energy is converted to heat and the battery heats up. So that's enough points for 5 marker.